Hello and welcome to our demo about a multimodal transfer of control from a human to a robot in a pick-and-place scenario. In this demo, we want to show you how we can rapidly teach a robot how to pick up cases from a conveyor belt and place them inside a box on a workbench. In order to do so, we will use multimodal input data, for example the speech and pointing gestures, which we will fuse inside our multimodal dialogue platform StepDP and make out commands of it for the robot and teach him in a natural and flexible way how to do this task. And what this looks like is what we're going to show you now. So here we are back fully equipped. As you can see, I am wearing the Microsoft HoloLens 2, which is detecting my speech and also my pointing gestures. So the Microsoft HoloLens 2 can detect where in the environment I'm pointing at. And we can use this input now to teach the robot how to grasp an object, in this case our case from the conveyor belt, and place it inside this box on the table. We have prepared 3 different runs, which all highlight different features of our implementation. The first run is a version where we go through the dialogue model step by step, so that you can see how it is built up, how it works. In our second run, we will interact a little bit more natural with the system, which means that we will also have some built-in errors and the system has to react to it. And our third run is the expert run, so where we try to provide all the necessary information to the robot at once. In our first run, we want to teach the robot step by step how to do the task. And it needs to learn different parameters in order to do so. It needs to know what to pick up, the case, how to pick it, so the grasping pose, where to place it in the end, and how to release it. And we will do it now step by step. And I would start by initializing the task and saying, I want you to pick and place something for me.
I can help you with that. What shall I do?
So the concept of picking and placing is known to the robot. That's what it does and is usually in the assembly task as well, when it picks up cases and hands it over to the human worker. So the concept is known, and we can start teaching the parameter. And I could say, I want you to pick up those objects.
I understand that I am supposed to pick the case. Did I understand you correctly?
And by our multimodal fusion platform StepDP, we could now fuse the 2 inputs of my pointing gesture and the speech. Just from the speech, it would not have been obvious what I mean by just saying those objects, but by pointing at it, the robot understood that I mean the case. And I would confirm and say, yes.
How am I supposed to grasp the object? Which grasping pose should I take?
The next parameter is the grasping pose. And this might sound trivial to us humans, so we would probably say to a human coworker, well, just grasp it like that, somewhere in the middle, and we would intuitively know how to apply force to the case so that it does not drop or that we do not break it. But for the robot, it's a quite complex parameter, which requires a lot of detailed information. But what I have told you previously is that the robot assists during the assembly task and actually knows how to pick up those cases. And so we can say, I want you to grasp those objects like a case during an assembly task.
I understand that I need to move my arm into the case pose. Did I understand you correctly?
And by referring to a known task and a known grasping pose, the robot is now able to extract this information, and we just need to confirm and say, yes, that's correct. And it knows how to grasp the case from the conveyor belt.
Where would you like me to place the object?
For our last 2 parameters, the destination and the release position, we can just try to give them both at once, and we would say, just drop them in the box on the table.
I understand that I may drop the object, and the object needs to be placed in the box. Did I understand you correctly?
And as you might have noticed, I was giving the robot 2 parameters at once, and our dialogue model is flexible in a way that it's able to handle both parameters at once. And we confirm by saying, yes, that's right. And so the robot was able to pick up a case from the conveyor belt and place it inside the box. So we successfully taught it how to do so. But it was not really natural. That's not how you would probably explain it to a human coworker. And that's what we will see in our second run. In our second run, we will now try to interact a little bit more natural with the robot. We will build in some errors and a more natural behavior. And first we have to initialize our task again. So we would once more say, I need you to pick and place something for me.
I can help you with that. What shall I do?
I want you to pick up those cases and place them in the box over there on the table.
I understand that the object needs to be placed in the box. Did I understand you correctly?
What you might have noticed is that my pointing gesture was not really precise, so I was just referring with my thumb to the cases. A human co-worker would probably have understood what I mean, but the robot is not able to extract this information. What it understood was the destination, because I was pointing at the box on the table and referring to it, and so it just proceeds as everything would be fine and asks us if the destination parameter is correctly understood. And I would confirm by saying, yes, that's correct.
Understood. I'm sorry, but I still need you to tell me which object you would like me to pick.
And in this step, the system informs us that there was an error, that there is some information missing, and we can just continue with our input behavior. We will stay inside the flow and we are not interrupted. And I would say, I want you to pick up those objects.
I understand that I am supposed to pick the case. Did I understand you correctly?
Once more, we could see the multimodal data fusion and we can again confirm, yes, that's correct.
How am I supposed to grasp the object? Which grasping pose should I take?
As we have seen before, the grasping pose is a quite complex parameter and it's not that trivial to teach it. And as I also said, when you would explain it to a human co-worker, you would probably just say, yeah, just grasp it like that. The robot, of course, does not understand it, but we will now try to provoke an error and see what happens. Just grasp it like that.
I was unable to understand your description regarding the grasping pose. Would you like to move my arm into the desired pose instead?
And what we can see now is that the transfer of control is kind of reversed. So the robot wants to give us the control back by teaching it manually how to grasp the object. And now we would just say, yeah, why not? Yes.
Understood. I am initiating the teach-in program. You can move my arm in the desired position. Press the blue button and I will start opening my gripper. Press it again and I will stop. To confirm the pose, press the blue and the black button simultaneously.
So we have received a short instruction how to teach the robot arm manually the grasping pose. And as you can see, the gripper is blinking, signalizing that we can move it into the desired position. And we can start opening the gripper by pressing the blue button. Whenever we have reached the desired position of the gripper, we can confirm with black and blue. And as we can see, the robot is able to grasp the object and still knows about the destination, where to place it. But what is left as a parameter is the release parameter. And we can tell it, just drop it. In this run, we were now able to interact a little bit more natural with the system. We have some built-in errors in which we saw how the system reacts to those errors and how flexible the dialog model is. In our last run, we will try to pass all the necessary parameters at once, and we will see how this works. In our last run, which we refer to as the expert run, we will try to pass all the parameters at once to the robot. It is meant to act as some kind of version for an experienced worker who has been working with those robots for quite a long time, knows all the parameters and interaction principles, and can save some time by giving all the parameters at once to it. First, we would initialize the task again by saying, I want you to pick and place something for me.
I can help you with that. What shall I do?
Pick up those objects like a case during the assembly task and drop them in the box on the table.
I understand that I am supposed to pick the case. I may drop the object. I need to move my arm into the case pose, and the object needs to be placed in the box. Did I understand you correctly?
Yes, that's correct. And we can see that the robot was able to extract all the necessary information from our statement that we provided with speech and pointing gestures, and can now fulfill this task while we are away. Within the demo, we have now seen 3 different versions of how to interact with the robot, how to rapidly teach it in a natural way how to do this task. And that's what it can do now while we are away, and we are finished. In our demo, we could show you a multimodal transfer of control from a human to a robot in a pick-and-place scenario. And within the 3 runs, we could see how flexible our dialogue model is able to cope with error situations, how it can fuse multimodal input from speech and gestures. And by doing so, we could provide a really rapid teach-in, a natural teach-in for a robot, and tell it how to pick up a case from an assembly from the conveyor belt and place it inside the box. And we can now leave the scene and let the robot do its job.